happens when the plane is flying at supersonic speed or equal to the speed of sound. Okay, so we're going to look at 3 scenarios. So first of all, we're going to start with what happens before it reaches the speed of sound. First of all, there's going to be bow waves or pressure waves. They're going to be the same thing. They might be called V-shaped bow waves or pressure waves. They're the same thing. So these are just your Doppler sound waves, okay? Let's draw that. These are bow waves, also known as pressure waves. Okay, close enough. So these are, let's write that down with a better color. V-shaped bow waves, or aka also known as pressure waves. And they travel outward at the speed of sound. So they are sound, okay? Let's write that down. This speed is the speed of sound, whatever it be. These are kind of like when you have a boat and you're in water and you end up having these V-shaped bow waves. So this is kind of like that. Okay. Next of all, we're going to have what happens when the plane is traveling at the speed of sound. So bow waves are going to equal the speed of the jet. Bow waves equal the speed of jet. And what ends up happening is bow wave crests, which are these lines that I've drawn, bow wave crests are produced at the same location as the previous bow wave crest. So your next bow wave crest is still going to be produced here. It's going to be like that. And then your next bow wave crest is also going to be here, and it's going to be produced like that. Okay, so let's jot that down. The speed of bow waves or pressure waves are going to equal the speed of the jet. And they're going to be produced from the same location, and this location is the shock wave. The shock wave. It's going to be there even when it's at supersonic speed. And something that's notable is because they're all produced from the same location, from this shock wave location, unlike here you got these wavelengths, these leading wavelengths, but here there are no leading waves lengths. Okay, so it's zero. No leading wavelengths when you are traveling at the speed of sound. So there's no Doppler leading wavelength, but you'll still have trailing wavelengths. And then last of all, it's going to be really similar, except what happens now is your shock waves are going to form a cone. It's not going to be like your little round circle here. It's going to be a cone. It's like you got an egg head here and you got a crown head here. Okay, it's going to be a cone. And what else happens is you're still going to have those Doppler trailing wavelengths. Okay, so then what ends up happening is a supersonic speed shock waves will form a cone, and you got a sonic boom. And just something that I really want to point out here is to the question, where do you hear the sonic boom? So let's draw another diagram here. You got a plane, okay, you got a plane, and you got little Doppler waves back here, and you still got the cone here. Very dramatic. Okay. Now let's say you have 2 people. You have one person here who has not yet reached the plane, and you got a person here who has already had the plane pass him. So individual 2 is not going to hear the plane until it passes her or him. And individual 1 is going to only hear the sound after the plane has passed him. So if a plane was here, he wouldn't hear it because you got these wavelengths here. And if it's here, you might not hear it just yet. Why? Because if it's right here, if it's right above him, remember the plane itself is traveling faster than sound. So that means the plane might pass a person before they actually hear the sound, because the plane is faster than the sound.